Hello everyone. Today I'm going to go over how to wire a robot drivetrain just from the basics. So before we get into any wiring, we first need to go over the key components that are going to be used when you're setting up your robot. So over here, this is the battery of the robot. It's 12 volts and uses 4-gauge wires to be able to handle high current. This is where all of your robot's power comes from. So for all of your motors, all of your sensors, everything, all of its power is going to be drawn from here. Next, we have the circuit breaker. This is like the main breaker for the robot, and it's rated for 120 amps. So if the robot is drawing too much power, it would stop it. It would stop the current flow to prevent fires or other issues going on. This needs to be easily accessible within the robot, so you can turn it on and off easily. Because this is also how you turn on and off the robot. So this red button over here is how you turn off the robot, and this switch over here is how you turn on the robot. So when you push it in, the robot's gonna be on. When it's out, that means the robot is off. Next, from the switch, the power is gonna go to the power distribution hub. So this basically takes all the power from the battery after it goes to the switch, and now allows you to actually send it to different components in your robot, like motors or the Rio, which we're gonna get into later. So over here, there are a bunch of Wago terminals, where this is basically where you put in the wires of the motors, and so they could draw power. And these are smaller Wago terminals for for components that need like more specific voltages or currents that are more controlled. And this is where it receives the power from the battery and from the switch. So next we have the Robo Rio, which is actually the brain of the robot. It runs code, it reads sensors, and it also controls the motors to the CAN bus. So this is also the starting point of the CAN bus. That's for the Rio. So next, let's go over what the CAN bus is. So the CAN bus uses these yellow and green wires, and basically that's how you control and communicate to the devices on the robot. So this is how your Rio communicates to motor controllers and sensors and things like the gyro and CAN coders. So next, what we're going to be using on this robot is a thing called the CAN of War. So basically, this sets up a second CAN bus for your robot that's faster and more optimized than the Robo Rio's CAN bus. So we're going to have one CAN bus coming out from the Robo Rio and another one coming out from the CAN of War. And we're going to be using the CAN of War because it's faster for all the drivetrains. So we can have faster and better odometry. So it's going to be connected to all the drivetrain motors and the swerve pods, the gyro, and all the CAN coders on the swerve pods. So make sure everything communicates quickly so we could run faster autos and communicate faster with the robot to move. So next, over here, we have the Pigeon 2.0, which is the gyro for the robot. It measures the robot's orientation and motion. This is where the CAN comes in, and then the CAN could come out over here if you want to daisy chain it. And this is for the power. This wire over here is the power for the Pigeon. And the Pigeon is going to need a more regulated voltage, which we'll go into later. Next, we're also going to go over the motors that we're actually using on this robot. So on the robot that we're going to be wiring in this video, we're going to be using a Falcon 500 with a Talon FX motor controller. And these use 10-gauge wires. These use 12-gauge wires, but for the Krakens, which we actually use on our main competition robot, these are going to use 10-gauge wires. So just make a note of that difference, but this is what we're going to be using in this project. Next, what we also want to go over are the CAN coders. So a CAN coder is basically an encoder that communicates over the CAN bus, and it can tell your robot the position or rotation of a mechanism using this magnet over here. So we're going to have one of these on each of the swerve pods, so it can measure the angle that each swerve pod is at. Okay, next what we're going to go into is the VRM, or the voltage regulator module, which converts 12 volts from the battery into either 12 volts or 5 volts that's regulated so the amperage is going to be more controlled and consistent. And this is important for sensitive electronics like the radio or the sensors, as we need steady voltage for this. Finally, what we have is the RSL, or the robot signal light, which shows the robot status. basically if it's on and just if this color is solid, that means the robot is powered, but it's not enabled. And when it's blinking, that means the robot is enabled, so it could drive, it could move around. And that's when you know you have to keep your hands out of the robot. Over here, last of all, is the radio. This is how the robot communicates with the field, communicates with your controllers, and allows you, and basically is how it just connects to everything. So this is really important. Okay, now that we know what the key components are, let's take a look at the project that we're going to be building in this video. So we are given this empty drivetrain with just the swerve pod setup and nothing else, and just the belly pan. So our challenge is going to be to figure out how do we want to set up all the key components and wire the drivetrain and get everything ready for like testing. So as you can see here, we have a battery slot already built in. This is perfectly measured for the battery, so we're definitely placing the battery there. But then we need to figure out how do we want to source the power from the battery into the switch and into the Rio and into the PDH, and then also how to wire and set up all these swerve pods over here. So this is what I came up with as a plan. We place the battery in a slot over here, then we send the power out to the switch right up here, and then from the switch it's going to go into the PDH down to the Rio over here. And basically this keeps things easily accessible for wiring, so the motors can go into here, into the middle, and it makes sure that we don't have to do anything super complicated to get everything access to power, because it's in a central position. We also want the pigeon, which is the gyro, to be close to the middle so it gets more accurate readings. And the canivore has to be pretty close to the Robo Rio, just make sure it's consistent, and also because the USB cable is not super long. We also just want, this is not perfect, but due to the way this drivetrain is laid out, we place the RSL over here. Normally you're supposed to have it on a high elevation so that like people could see it from like multiple feet away, and so people can know whether the robot's on or not. And also over here we're gonna have the radio, which needs to be elevated also, so it allows for like better more consistent communication with the field and with the driver station. And also it needs to be attached to some metal plate so to allow for better cooling. Okay, now let's go into how we're actually going to plan to wire this thing. So this is a diagram of the CAN bus that we're going to be using. The CAN bus starts at the Rio over here, and it's going to go to our canivore. So we're going to be, because we're just wiring a drivetrain, almost everything that we're going to be doing in this robot is going to be using the canivore's CAN bus instead of the Rio's CAN bus. But the Rio's CAN bus would be used for things like that don't need as fast of an update time, like elevators or wrists or shooters. But for the purpose of this video, everything's going to be coming out of the canivore. So we're doing a kind of hybrid version of a CAN topology, where we have one main loop over here, but also we have hubs with multiple things coming out over here. This is just the standard for a team. This is what we've been using for a while. So what we have at each hub, we're gonna have a Wago terminal. This allows you to connect everything into the CAN bus. So once we get to the first swerve pod, you're gonna have a motor for the driving motor. We're gonna have the CAN coder also, and we're gonna have the azimuth or the rotation motor for the swerve pod come into this, and then it all meets at this hub. And then we're gonna go on to the next part. We're gonna have to stop quickly and include the pigeon in line into the drivetrain CAN bus as well. And then we're going to go on to our next swerve pod. So include again the motor, the encoder, and the other motor all in a Wago terminal. And then there's going to be an input going into the Wago terminal. It's going to have all the motors coming in, and then we're going to have another wire going out to the next swerve pod. Repeat again, then repeat again. And then one thing that's super important to note for a CAN bus is that it needs to terminate at a 120 ohm resistor. So the PDH has these built in for the CAN bus where you can just place it in, and that'll be the termination point. So that's what our CAN network is going to be like. And also to power the encoders, one thing that we have to note is that the encoders are like sensitive, and they need to be used, and they need a more consistent voltage coming out. So we're gonna have to be using the VRM. And because of that, the thing is the VRM has very limited slots for us to actually put in the powers. So we're going to actually have to combine all of these encoders into a Wago. And then from one Wago, then it's going to get sent into the VRM over here, into one slot. So So that's how we're gonna power the encoders, and we just have pretty long wires for the encoder's power. Okay, now we're going to go over how we're actually going to start wiring this robot. So this is how the battery is going to look like once it's inside the robot. So it's going to have the 4-gauge wires coming out to the Anderson connector. Now we need to figure out how to place and connect everything else to the switch and then to the PDH. So now that we know where the battery is going to go, now we need to set up the switch. So the switch has the other end of the Anderson connector, which is going to connect to the batteries one. And that's how we're going to actually connect the rope. When we change the battery, we're just going to place a new battery in and then connect this to the switch, so we can power the rest of the robot. So you need to make sure that you crimp these wires, and so they could be attached onto the switch like this. And then also what you want to do is you want to make sure you have electrical tape to prevent any short circuits or prevent anyone from getting shocked when they touch these, because these are going to be powered. And they also have these caps over here that can go over this, just to make sure no one touches and there's no short circuiting. And then, so the red wire, the power is going to go into the switch, and then it's going to, after it like regulates the voltage, then it's going to be ready to go into PDH. But the ground wire can just go directly from the battery to the PDH. So now this is how you connect these wires to the PDH. So once we have the red wires connected over here, then you can just insert it into the terminal on the PDH over here. You want to make sure that there's no wire sticking out. So this one was crimped a little bit. This one was stripped a little bit too much. You do not want any wire to be exposed. You also need to make sure that when you tug on it, if you want to tug it out, you make sure it doesn't move at all. Otherwise, because what's going to happen to the robot on the field is going to be way worse than what you just pull on the wire. So you need to make sure that these are really in tightly. So it should be around 3/4 inches stripped, so it doesn't stick out. So next, so this is basically how it's going to look like when we place it on the robot. We're going to have the PDH over here. We're going to have the switch in this corner. And this is how we can easily connect the battery into the switch. So it's pretty easily accessible to plug in. All right, next we need to wire the Robo Rio to the PDH. So basically, the Robo Rio is going to need the more regulated voltage and amperage coming out from over here. So we need to set up. This is a breaker. So this is just make sure that the current the Rio is drawing isn't going to fry it. It's going to be too much. So if the current goes over 10 amps, then it's going to break the circuit. It's going to stop it. So we protect the Rio. But basically, we're going to have to set up wires from over here into the power over here for the Robo Rio. So this is a 10 amp mini fuse. You need to make sure you have the 10 amp mini fuse, and we're going to be using 18 gauge wires, so a little bit smaller wires to connect to the Rio. So once we do that, this is how it's going to look like. The wires going into the Wade-Muller terminals over here. You're going to need to press down on it with a screw and then insert the wire in here. And then you want to make sure that you cannot see any metal sticking out. So again, this wire was stripped a little bit too much. You should not really see any metal at all. And then to actually connect it into the Robo Rio, you could actually just unscrew this input thing, so it's a little bit easier access. And then just when you want to put the wires into this terminal, you want to screw it down. There's these little screws you can tighten over here to make sure that these are fully inserted, and if you tug on it, they won't come out. And you can just push this back into here, and that's how you power the Rio. So this is how it's going to look like in the end. So it's coming out from the PDH with a 10 amp mini fuse, and it's going into the Rio like this. So now you've set up the connection from the PDH to the Rio. Okay, so next what we want to set up is the robot signal light, or the RSL. So the robot signal light is going to be powered from the Robo Rio in this port over here labeled RSL. So it's pretty clear. So what we did is we just mounted it onto the side of the frame. This is not a perfect location, but it's good enough for the example that we're going to do now. And there's going to be so the wire that we used, we reused the old wire. So it doesn't really need to be this white wire at all. It's just going to be the red and the black wire coming out from the RSL, coming out from the Rio to the RSL. And you're going to put the black wire into the middle node of the RSL labeled N, and then you're going to put the red wire into the node labeled LA. And then you're going to want a jumper wire going between the two, from the LA to the LB. And this basically allows you to control like whether it's flashing or whether it's a solid light coming in. So that's how you set up the RSL light. It's pretty simple. You want to make sure that the wire isn't too tight, and if like you're tugging on the wire, you're going to want to use zip ties and attach it to somewhere else, so that when you tug on it, it's not tugging on the connection, it's going to tug on the zip ties instead. That's just how you make sure everything's going to like stay safe during the actual competition. So again, this is how the terminal looks. This white wire, there's actually no terminal for a white wire over here. The only things that are actually connected is the black wire and the red wire to these two terminals over here. All right. So next, what we're going to set up is the VRM. So the VRM takes in power over here from the PDH, and then it could be distributed in a regulated amperage and voltage over here. So for the sensors. So again, this uses Wade-Muller connectors. You just need to press in with a screw over here and insert the wire. Make sure you can see no metal coming out. So just make sure it's fully in there, and tug on it to make sure that it does not come out if you pull on it. So again, this is how it's going to look like. We decided to place the VRM on top of the Rio just to save space. You don't have to do that, but it worked pretty well for us. And then this is how you want to connect the VRM to the Rio. It uses a 20 amp mini fuse, also 18 gauge wire. So you just insert it into the connectors over here, make sure it doesn't come out, and now your VRM is connected. So that's pretty simple. All right, next I'm going to briefly show you how to solder a can coder, because when you receive a can coder, it's just going to look like this. There are no wires attached to it, and you need to attach them yourself. So basically, this is our soldering station. We're holding it up using these two things over here, just to make sure that we're able to use both of our hands to actually manipulate the wires and like do everything accurately without having to worry about holding these up. So this really helps a lot. So first, you're gonna have the wires like this. They're not gonna be stripped at all. So and you can't solder an unstripped wire. That's not how it works. So you have to strip it less than an inch. But if it's too long at the end, you could just cut it off later. So it's not too much of a problem right now. And then you want to insert the wire into the respective holes on the can coder. So it's gonna be labeled. So over here we have the green wire going into the part labeled into the hole labeled green. It's going to be on the opposite side, so you can't see it from over here. But once it's in like that, we just bend it to the side a little bit so it doesn't come out, and then you solder it. So you're going to want to use a soldering iron and some solder, and then just like get it onto it so it's just fully connected like this. So and then you just want to cut off the extra wire so it doesn't touch anything else. So we soldered it in one port. And you have to repeat it for the yellow wire and the red and the black power wires too. So in the end, it's going to look like this. You have the can wires set up over here, and you also have the power wire set up over here. And this is the label. So ground, the black wire goes in here. Power, the red wire goes in over here. Green and yellow. So this is where you know how to put the other ones in. So that's how you solder a can coder. So now we're going to attach the can coder to the drivetrain. So the way the swerve pods are set up, it already has a magnet in there. So all you need to do is just screw down the can coder into the screws that are already made for you over there, into the screw holes that are already made for you. You want to first do the base plate, then put the can coder onto that, and then make sure that the wires are ready to be accessed and facing the right direction to connect to the rest of the robot. And then you just want to screw over the top, and then your can coder is ready to be wired. So that's how you attach it to the actual swerve pod. Okay, now we're gonna show you how to set up the radio and how to connect the radio to your robot. So the radio is going to be communicating to your Robo Rio through this Ethernet wire. So there's a designated port on the Robo Rio. You put it in there, and doesn't need to be very long because the injector, the power over Ethernet injector that we're using is already pretty long. So this just has to be pretty short. So this is basically a diagram of what it's going to look like. We're going to have the Ethernet coming out from the Robo Rio. We're going to have power coming in over here from the PDH. It's going to combine the wires into two, and then we're going to plug it into the place labeled Rio on the radio. So that's how you actually connect the radio to the rest of your robot. And then if you want to do like testing with a drive station or any of that, then you could also use that. So again, the Ethernet from the Rio gets plugged into over here onto the injector, and then we're gonna put the injector into the radio. And also for the power, From the diagram, again, it just goes into the PDH, into this section with the regulated voltage. You want to set up a 10 amp mini fuse just to make sure that the radio doesn't pull too much power. And then you want to attach the radio onto a piece of metal that's a little bit elevated, because we only have a drivetrain that doesn't have to be super high up, but on other robots it's gonna be like on the side of the elevator, and then we just zip tie it down. Normally, so normally teams just zip tie it down, and then that's how it's just connected. Now we're gonna set up the Pigeon 2.0 and the Canivore. So the Pigeon 2.0 is normally gonna be bolted onto the belly pan of the robot, but because this is for testing, we use double-sided tape. The power of the Pigeon is going to come out from over here. This is sensitive, so it needs to use the VRM, also for its specific amperage requirements in the documentation they specify. Because we can also connect it to the special ports on the PDH, but because the PDH only has 3 ports, it's already taken up by the radio, the VRM, and the Rio. We're gonna have to connect this one to the VRM. And this is also where the CAN bus comes in. So we could just attach it in line into the CAN bus, comes in over here, comes out over here, and just move on to the next swerve pod. This is how you set up the Canivore. So the Canivore could be powered over USB-C, straight from the RoboRio. So it attaches the RoboRio over here, and then you plug into the USB-C into the Canivore. So this transmits all the CAN bus information for the signals to control everything on this CAN bus, and also provides the power. Optionally, you can power it through these ports over here, but since you could just use the USB-C for power, we don't really have to do that. And then the CAN bus is going to come out from over here. So you want to keep this pretty close to the RoboRio. So now we're getting started on building the CAN bus. So we have the CAN wires coming out from the Canivore to start the new CAN bus, and these are going into the Wago terminals. And this Wago terminal is going to be attaching to a swerve pod, so the encoder, the motors, and everything is going to go into here, and then there's going to be another wire moving down this way to connect to the next swerve pod. So this is how we set it up. We're going to change this later so that it goes to the swerve pod back here, just so that it terminates nice and easy at this swerve pod over here. But basically, this is the concept. We're gonna put in the for each motor controller, we're gonna put in their CAN wires. So 2 of them into here. The yellow ones need to be into one Wago terminal. The green ones, the high voltage ones, need to be into the other Wago terminal. So never mix the yellow and the green wires into the same Wago terminal. That's gonna not be good for you. So we actually have 2 Wagos sat on top of each other, one for the yellow and one for the green, and we're just inserting the yellow ones and the green ones into their respective terminals for the motors. We also, just because we don't have an encoder right now for this specific swerve pod, we're just putting the Pigeon into the Wago terminal as well, just because we can. And then we're gonna have another wire going on to the next swerve pod like that. So when it's completed, it's going to look something like this. This is a little bit messy. You're gonna have to do some wire management later, but just for the concept, it starts off with the Canivore over here. We're gonna connect through to these motors over here. There would be another encoder over here too. Then it moves on from this Wago onto this swerve pod. So encoders and motors all coming in over here. Then it would go on this way. The Pigeon would be in line. Moves on to the next swerve pod. Again, motors and encoders going over here. Moves on to this one, motors and encoders. And then it's going to terminate into this specific port on the PDH over here. And that's how you end the CAN bus. So for the CAN bus coming out of the RoboRio and the CAN bus coming out of the Canivore, they're both going to terminate over here. That's why you have two separate terminations for the red and for the green and yellow wires. So this is how we're powering the CAN coders. So we're gonna have 4 CAN coders in total. So that's why, and there are 5 slots over here. So each CAN coder is gonna send it. So we're gonna need a separate Wago for the red and a separate Wago for the black wires. So all the red wires from the 4 CAN coders are gonna go in over here. All the black wires are gonna go into the Wago underneath it. And then we're gonna have just all pulled into one wire going into one specific slot on the VRM. So we're gonna be using the 12 volts with the 2 amps regulated ports for the VRM. So that's how we're gonna power all the CAN coders. So another thing that you have to do is you have to power the motors. So this is pretty simple. You just literally just plug the motor into any port on the PDH, and they need to put in the right breaker over here so the motors can't pull too much current. Otherwise, that would be bad for the motor and bad for your robot in general. So For these motors, these Falcon 500s, we're using 12 volt 40 amp motors according to the documentation. You should always refer to that when you need to figure out what breaker to use. So for each motor going in, we have the respective breaker over here, just like that. So that's how we power all the motors. And then you can also see the only camcorder that we have on here is getting powered by the VRM after it goes into a Wago over here. So once you get all the wire management done, it should look something a little bit more like this. There are wire highways going by where all the wires are attached to, all of them zip tied together, so it doesn't get messy, it doesn't get caught in anything. And if any of them gets tugged on, it's gonna be tugging on the zip ties rather than the connections themselves, because that'll be very bad. So again, just in the last overview, goes in from the battery. It connects with the Anderson connector over here. Goes into the switch. From there, you need to send it to the PDH, and then from the PDH to the Robo Rio, and then everything else just goes on from there. So that's how you get started on wiring the drivetrain. Thank you for watching.